Proceeding, I would like to introduce our next speaker. And the title of this presentation is Fragmenting DeFi Infrastructure and the Need for Abstraction. I'd like to warmly introduce Philipp Zentner, founder of Li.Fi. Philipp, thank you very much.
Thank you.
Hey, appreciate it.
Hey guys, thank you for having me. I'm Philipp. I'm one of the founders of Li.Fi. I do have a technical background. Been building for the web for the past 20 years almost, yeah. And my co-founder and I, we have a long history in building very data-driven businesses. We spent time in the gaming industry and biotech as well as marketplace intelligence. So there is a long history of building very data-intense businesses. And when we entered this space, just beginning last year, the very first impulse we had was, if this is supposed to scale, it has to be multi-chain. And so lucky enough, the first hackathon we did was scaling Ethereum. We were facing different teams from scaling technologies like Optimism, Arbitrum, but also bridging technologies like Connex and Hop. So first day, interoperability, and our thought was someone has to abstract all of that away. If we look at like 2 years ago, I think the most important smart contract-enabled blockchain was Ethereum, but today that's not the fact anymore. I mean, this chart here is a little outdated, but we can see that there are a lot of value locked on different chains. Maybe we can ignore Harmony and Terra for a second here, but yeah, it's been a multi-chain world. The reason for that is multifold, I guess. In general, we expect that developers are going to pick blockchains like they pick their databases today, right? All these databases provide the simple option of saving, like writing and reading data, but we have timescale databases, we have relational databases, NoSQL and document storage databases, data lakes, and all of that. And all of these use cases all of these solutions serve different use cases, and they come with different flavors, frameworks, tooling, and we expect the very same to happen for the blockchain industry. You might go to Solana for high-frequency trading, to Tezos for your NFTs. If you seek more censorship resistancy, you might want to go for Ethereum. And as we progress and have new findings on how to solve these cryptographic problems and make them more scalable, we simply might add up with more and more blockchains that have better algorithms. So it's going to be multi-chain, and we can also see how liquidity is slowly getting put out of Ethereum L1, right? Here we see a bunch of bridges, and that's by far not all of them. That's almost just native bridges here. And liquidity has been flowing out to other ecosystem. So the need for aggregation becomes stronger and stronger. Let's quickly talk about bridges, or not quickly, actually the majority of this talk is about bridges. Blockchains, due to their consensus algorithm, cannot talk with each other unless it's been incorporated from the get-go. We see this in Polkadot, we see this in Cosmos with their own interoperability protocols embedded from the get-go. But in general, if we want to move assets from one chain to the other, we need a man in the middle that looks after these assets and can basically decide, all right, a user like Alice here has locked funds on the source chain, so now I can unlock them on the destination chain. There are different kinds of bridges. Some have lock and release mechanisms, others burn assets, like completely dissolve them on the source chain and then have the capability to mint them on the destination chain. For that to happen, a project has to opt in for that specific bridge, and that's also why we saw incredibly huge valuations for projects like Layer 0 and Axelar and Nomad and so on, because these bridges have a certain lock-in effect regarding these projects as their assets are tied to these bridges. But the problem here is we are somehow introducing a middleman, right? And the whole thing, like the whole reason why we're here and talking about decentralized infrastructure is we want to get rid of middlemen. So we have trust assumptions suddenly. Suddenly there is someone we need to trust, and we need to ask, like, who is verifying this system and what would it cost to corrupt it? Now, we can roughly distinguish these bridges in 3 different kinds of verifications. We have natively verified bridges. Those are, the way that works is essentially blockchain A has a light client of blockchain B included and the other way around, so they can reach each other, but in a huge multi-chain environment that doesn't really scale, right? It has to be implemented for each new chain on each side. It has to be maintained, and that doesn't really work out. Some ecosystems have foreseen this from the get-go. Polkadot has XCMP and XMP, like cross-chain communication protocols, included from the first second on. Also, Cosmos with IBC is a good example for that. But for Ethereum, unfortunately, that doesn't work out. We also have externally verified system. Externally verified is the complete opposite of natively verified ones. We have a third party, often driven by multi-sig thresholds, MPCs, or oracles, and we really have trust issues here. We need to trust these systems, and the largest hacks we have seen in this space have been on bridges, and these largest hacks on these bridges were mostly externally verified bridges. In fact, around 80% of all the bridges we see are externally verified. They are the easiest to build. So you can also call it a lean go-to-market strategy, but yeah, we're talking about a lot of money, and in general, we try to get away from them as much as possible. There is also locally verified ones. They are kind of a hybrid. The way it works is we have a certain set of validators on each side that have a light client, and they can talk in a very atomic way with each other. So Connex and Hop are such examples. They are not trustless, but they are as trust minimized as it can get. All of these bridges have to face the interoperability trilemma, that essentially means you have to decide on between generalizability, which means how much can you do with it, because there's more than asset transfer a bridge could do. It could transfer all kinds of data, right? So generalizability, layer 0 is maxing out on that. In fact, layer 0 is not even a bridge, it's a relayer network. It can build on top whatever you want. Then we have extensibility. If you have listened correctly, like Light Client, for example, they are really bad at extensibility, right? It doesn't scale at all. So extensibility essentially says, like, how easy is it for a bridge to go to other ecosystems? And then we have the topic trustlessness. We already spoke about that, like how secure is the system? What would it cost to corrupt it? And all these bridges have to take different trade-offs. And yeah, they do. And it's difficult. So if we take a So the bridging space is quite big. This is just a short idea, and I want to dive into a few and tell you what makes them special. Connex, for example, was one of the first bridges that allowed contract calls on a destination chain. So I could bridge assets and call different smart contract in one go. Incredibly useful. You could use it for all kind of cross-chain strategies. Hop has been focusing on L2 to L2, so they have really optimized this particular part. They have batch transfers, very gas efficient between Arbitrum and Optimism, for example. We have bridges like ThorChain. They took care of bringing BTC over. Layer 0, Abacus, Axelar, Wormhole, Nomad are arbitrary data messaging bridges, so they are maxing out on generalizability. You can build a lot of stuff on all of that. Yeah, this space is expanding almost weekly. It's crazy. We haven't even touched native bridges here. Stablecoin's going to release their own bridges, and that's super exciting because what you have to understand is, as lots of these bridges work with lock-in release mechanisms, that means they need liquidity. So they need to source liquidity. If they need to source liquidity, it means they need to reward people for providing liquidity. So they have a huge topic called capital efficiency, right? Now, as stablecoins come into play and release their own bridges, because they have zero cost of capital, it doesn't cost them anything to attract capital, they will completely change the bridging environment again. NFT bridges, a huge problem from my perspective, because like the value proposition we gave towards artists was, hey, sell your art on chain and avoid secondary markets, right? If you would start selling my art on chain and someone pays me $100 for it, and then the day after he resells it somewhere else, I have a royalty mechanism. I can profit from future sales. But once I start bridging my NFT to another chain, to another ecosystem, I again have created a secondary market. I have no control about that unless we start standardizing royalties, unless we create new standards that are respected by all the bridge builders in order to let royalties flow back to the source chain. Difficult. Application-specific bridges become necessary as we have application-specific chains. DYDX just chose to go back from Starknet to Cosmos and have their own app chain. This is difficult. What about Ethereum decides to start scaling via sharding? Do we have an inter-shard communication channel? How about data availability layers? This whole infrastructure play is just starting to fragment. It's incredibly difficult. So, for us, it's the #1 challenge to aggregate all these different bridges to allow any source and destination chain flow without you as a developer having to worry about which bridge to use. So we're reducing your time to market. You don't need to integrate all of these solutions. You don't have to maintain all of these solutions. Just to give you an example, Connext has released their 3rd major revamp just within 1 year. Last year in April, they were still on state channels. In July, they released NXTP. It was an on-chain and trust-minimized approach. And just 1 year later, now they are about to launch Amarok. So there is a lot of maintenance overhead coming with it. Also, we provide fail safety. What if a bridge gets hacked? We have seen plenty of bridge hacks, right? What if a bridge is drained out of liquidity? In June, July, we had that incident with Hop, one of the most favorite bridges in the community right now. But yeah, they were drained out of liquidity. And if your product is dependent on these bridges, you have a problem. Your product is de facto broken at that moment. So you want to make sure you have fail safety. And you might need optionality. Your risk profile might change. So not only in general as a company, but it might also change in terms of you can change it on a per request basis. So let's say you have a diverse user base, and that user base has different risk profiles. You could programmatically decide, well, for any transfer below 10K, allow all the bridges, but for any transaction above 10 million, please only use those two. So we're positioning us in a very neutral way. We consult our clients based on the risk profiles they have, and they can programmatically change which bridges to use and which not. Yeah, and also your priorities might change. Today you are active within the VM context, but let's say you're a market maker or a hedge fund or on-ramp and you need to rebalance your liquidity pools. You need the flexibility to go to other chains, other L1s like Solana, Near, and whatever might be hyped tomorrow, Aptos, Sui, who knows. And for you, it's going to be a constant pain to solve these issues for yourself. So instead of you having to reinvent the wheel, we take care of that. An additional problem is the overall immaturity of these projects. The founders are often quite young. We have plenty of first-time entrepreneurs. APIs look really ugly. APIs are a huge problem in this space. Yeah, the immaturity, the lack of standards, all of that makes it really hard for you. And we just chose the pain to solve that for you. Standards are on their way. There are chain-agnostic improvement proposals. I can recommend to look this one up. There is a proposal for cross-chain execution within Ethereum, just proposed by OpenZeppelin EIP 5164. And of course, like within ecosystems like Polkadot and IBC, we have these standards given. On our side, it's a continuous optimization problem, but it also creates a huge technical moat, right? The market entry barrier for anyone that wants to do the same we do, it's hard. Yeah, we will probably expand towards lending protocols, so you can adjust your liquidity flow without changing a portfolio. And multi-hops come with a whole set of new problems like slippage and MEV. So there's a lot to tackle. If you want to learn more about this, just contact me, build on us, and yeah, also we are hiring. So any data science, engineer here that seeks a new challenge, hit me up. Thanks.